Okay, I think we're good. Good morning, everybody. Welcome on in. I'm going to wait a little bit to take roll, which I have to remember to do. But I'm going to wait a little bit to take roll just to make sure that we have most people in here by the time I do that. So welcome. Welcome back. So we're going to move through some stuff. Couple things that I want to point out today. I got my list here of what I want to go over. Right. So let's just kind of review real briefly. I did find a couple mistakes in the syllabus, so I'm updating the syllabus, and there is a slight adjustment to my office hours. I have to slightly shorten my morning office hours, and then my midday office hours will then get extended. So just look for that in the next day or two. There'll probably be an updated syllabus with adjusted office hour times, but they're more or less going to be the same, roughly the same as they are now, just slight adjustments to it. So you can look for that in the syllabus if you care. And then what I want to show you is hopefully, I saw that some of you, I think it was 8 of you maybe, which is for this class, about a little less than half of you got in there and set up your homework account. Good job. For those of you who did that, good work. To the rest of you, please remember, you do not have to have any money today to set up the homework and get started on the work. Okay, you get the 14-day free trial, and then even then, the bookstore is still going to provide you with semester-long access for free. But that sometimes takes a few days or takes a week, and students will say, oh, I'm not doing the homework yet because I didn't get my license yet from the bookstore. You don't have to wait for that. You can get started today and work on your homework while you're waiting to coordinate with the bookstore to get that homework going. So please do not procrastinate. The reality is every day that passes that we get closer to the end of the semester gets harder, right? Because you're going to have projects you're working on and essays that you're working on for English classes and chemistry labs and all that kind of stuff. It starts to pile up. So the sooner you can get a jump on stuff now, it just creates less stress over the course of the semester. So please get started on that. And if anyone tried to sign up but didn't get wasn't able to, please see me. I think I forgot to mention this. I don't remember what. There was a question in one class. I don't remember what class it was. I think I may have forgotten to mention this in class. A lot of times the online homework platforms don't work on phones. Notoriously, the iPhone, usually you can't do My Math Lab or My Stat Lab, any of those products. You can't do them on the iPhone because it blocks Flash. I think they still use partial Flash player for in order to do this, which is probably on your computer, but probably not on your iPhone. So keep that in mind. Don't use the default browsers, Edge and Safari. Those do not play well with most online homework platforms. If you're having trouble, Chrome works usually, but Firefox actually seems to work the best. Even though it's not my favorite browser, it's a good browser. It's certainly better than the Safari and Edge. But it's really great for the online homework platform. So if you're having trouble, make sure you do that. So please get that up and started, and then you can get going. That January 24th seems like it's a long ways off, but you have a chapter's worth of work to do, and it actually is not that far off. And remember, I'm giving extra days to complete chapter 1 because I know people are getting stuff set up, but that chapter 2 homework doesn't follow too far behind the chapter 1 material. So you don't want to be waiting until the due date to turn in all the chapter 1 stuff, because then you've only got a week to do the chapter 2 stuff. You want to be working a little bit ahead so that you have that flexibility to not have to stress yourself out and try to do stuff under the gun. Okay? So keep that in mind. And then you can see at the end of chapter 1, I have released the beginnings of the project. We'll talk a lot about the project today. We'll talk a lot about the project over the course of the semester. And I really hope that at some point in the near future, we're in a classroom, because then you're really going to be able to help each other out better, help each other through the project and work together. So I'll talk about that a little bit. Just be aware there's now a discussion assignment. These discussion boards that are on Canvas, those are project points, and they're the easiest project points to get, okay? The actual final project when you turn in is graded with a little bit more scrutiny. These are not difficult to get. I mean, you can't be completely lazy and just leave a comment that says, good job. You're not going to get credit for that. But just go in here and do what you want, basically, or do what's being asked of you. For the most part, it's just I'm getting you to that next step of the project and at least begin that next step of the project. So like what I'm looking for in here is usually not a finalized version where you have everything streamlined and perfect. Like for instance, when we get to the part on correlation, I'm going to have you post your results on there, because what I want to see is that you know how to get into StatCrunch. You know how to run regressions and correlations using StatCrunch. You know how to take the image for your scatter plot and your correlation line. You know how to take that and put it into, here you would just be posting it. Later you'd be putting it in your project, and that you can make some kind of sense of the correlation and regression and make an interpretation. It doesn't have to be perfect, because you'll be doing it right when you learn it. So I'm not expecting you to be experts, but pretty good at it. So as long as you've done the basic steps, I'm generally going to give you points for these project discussions. As long as you went through and did it. I'm not like scrutinizing, doesn't seem like you perfectly understand it yet. That's more for the project when you turn it in. Here I'm just making sure you can do the basic steps to continue your work on the project. Okay, and this first one's real easy. You're basically going to form some groups that are going to work together. So there's a good question. When we're in person, are we still going to do our homework online? Yes. So the homework, the way it's set up in Canvas, that's how you will do your homework all semester. So we will still be using Canvas quite a bit. I think this is just a lot of things are going to not go back to quote unquote normal as the pandemic eases in the coming, weeks and months and years. Hopefully we start to get back to some kind of normal. But things are not going to go back exactly to how they were before. Many people are going to remain remote working, even though they can go back to their work, just because certain employers have decided that works for them. It's the same with teaching. There are some things that are just not going to go back to the old ways. And one of those things is most of your professors will be using Canvas much more than we did before the pandemic, because we've seen that there are certain things we can do in Canvas that really does help students, and also give students the flexibility so that if you are sick or you miss class for personal reasons, not regularly, but stuff happens here and there, your kids get the flu or whatever, and you miss a class, a lot of the stuff we have in Canvas allows you to not lose as much ground when you miss a class. So yeah, the homework as we're setting it up will stay the same even when we're back in class. So that's a good question. Okay, so what you're going to do now, and I will spend a large chunk of today giving you a rough idea of how the projects are going to work, so that you won't have all the details, because we're going to talk about the project every single week this semester. But I'll start to give you a rough idea so that you at least kind of know, okay, I kind of get what he's talking about with the project. But you're not going to know all the details, until, you're creating the thing in week 18 or whatever. But you can do a lot of the work along the way. If you keep up with what I'm talking about, you keep up with these discussion projects, when you get to the end of the semester, you will have a huge amount of the work in your project already completed, right? Because you will have been doing it each chapter. And then at the end, you're just sort of making your video and putting it all together. Now, what I have found is very helpful is for people to form groups, especially when we're online. But the reality is, statistics is a confusing course for people. This isn't an algebra class where you show up and you watch me do a problem and then you just copy it. How to do it, like factoring. You watch me do 5 factoring problems, you do 20 of your own, now you know how to factor. Statistics doesn't work that way, because every statistics problem is different from every other statistics problem. there's considerations that are different for every statistics problem. In fact, I could take two people who are experts in statistics and give them the same problem to work on, and they will do it differently because they're going to make different decisions about how to do the statistics. What is the interesting part of what they're doing? So this is not a course where you can just memorize what I did and then, you regurgitate that onto the homework, and then you get 100% on the homework. Every statistics problem requires critical thinking in order to get through. So that's hard. That's a lot harder. It's easy to memorize and just reproduce what someone else did. It's a lot harder to think your way through. And that's what, this is why a lot of subjects, even where you kind of go like, oh, I'm kind of surprised for my degree that I have to take statistics because I don't necessarily think I'll be using that much statistics. I wonder why they want me to take statistics. Well, one of the answers is that if you can get through a statistics course, you have shown at least a remedial level of critical thinking and being able to piece things together that you haven't seen before. Like that's a skill that you're going to have to work on and get better at over the course of the semester, because that's just intrinsically how statistics works, right? If I do a study on the ages of people in my stats class, that's going to be very different than if I look at the socioeconomic status of people in my stats class. Every time you do a different thing in statistics, you have to think your way through the whole approach again. And that's actually really good. It makes this class more interesting. We're not just memorizing and repeating until my brain just has that, burned into it. You get to think and problem solve and figure things out. But it's also hard. So it's confusing at times. So I'm having you form groups to help each other out in your project. But I want to make this very clear because people get confused about it. You are turning in an individual project. Each assignment for your project has to be turned in individually. You are forming groups so that you can come together and help each other out, because the reality is every time we do something, at least one person in your group is probably going to be confused about what we're doing for that particular topic, and more than likely, more than one of you will be confused. But if you're working together, asking each other questions, answering each other's questions, figuring out together, looking it up in the book, and helping each other with the oh, this was in the homework, here's how you do that, and helping each other through, then that's a huge help. Right? Even when we're back in the classroom, it's a huge help to have people to work with. But I want to make this clear. You never in this class get points for someone else's work. You get points for your own work. So the people in your groups will be working on similar things, but each of you has to make your own post in the discussion, these discussion posts. I only grade discussion posts. I don't grade people's names that are in it. So sometimes someone might email me and go, oh, I think you missed it. Jennifer mentioned me in her post. So I get those points too. You do not. You get points for making your own posts, right? However, doing these projects completely by yourself is very difficult. So I'm putting you in groups so that you can work together and help each other. But you each will turn in your own video project at the end of the semester. You each will turn in your own, or you will post your own information here in these groups. So for instance, and I make sure I put it in here every single time, because no matter what I do, there's always some people who miss it. Make sure you read the directions, right? I know last semester I had probably 5 different students who ended up not passing the class because it was clear they never read the directions for anything. They just sort of watched what other people were doing and going like, oh, I'm going to do a similar thing. But they didn't really get it because they didn't read the directions. So like read the directions. So, like here I have project. The first thing you're going to do is form some groups. So here I just have it stated, okay, like all discussions in this course, this discussion is graded. Once we're past the due date, I'll come through and there's like this thing called Speed Grader, where I set it up. It shows me your post. I read it. I go, okay, this is on point. Here's 10 points. Go to the next one. Okay, you're on point. Here's 10 points. And I just go through, and then it gives you your points. So it gets graded. Those points will ultimately be part of your project grade at the end of the semester. And then here's the one that I want to make everyone clear, because I don't like giving people zeros, right? You don't like getting zeros. I don't like giving zeros. Like all discussions in this course, each group member must leave their own post/response, whatever you want to call it, a post, a comment, a response, whatever it is, you have to leave your own. You cannot say, oh yeah, Jennifer said I'm in her group, give me points for her post. No, Jennifer gets points for her post. You get points for your post. Okay, your comment, your response, whatever you want to call it. So you have to do your own in order to get credit. And in this case, like in all cases, it has to be a meaningful response. If someone went through and deleted your message, would we lose anything? Right? So things like, great, I agree, good comment, way to go. Those are low effort, meaningless comments. They don't help. You can leave those if you want to tell someone great comment or I agree with you, go, that's fine. But that will not be a comment that gets you credit. I will be looking for another comment that you actually, participated in, gave some information, improved things a little bit. Okay. So for this first one, you're just forming groups. So basically, I was hoping to wait until we were all in person so you could all kind of meet each other a little bit in class, give you 10 minutes to get to know each other, form your groups, whatever. But with each passing day, I'm less and less confident we're going to be in the classroom in week 3. So we'll just have to see how things go. So we're going to go ahead and get this started because I don't want people rushed on the project. If we wait until weeks 4, 5, or 6 to get started, that's not really good enough. So what you're going to do here in this first comment post, and you have like over a week to do it, but I wouldn't wait. You're going to introduce yourself. Just come in here, whatever you want to say about yourself. Mention yourself. And then whatever, introduce yourself, whatever is important to you. If you, maybe your educational goals, maybe you're a nursing student, and then some other nursing student's going to see you and go, oh, why don't I try to team up with this other nursing student? We're both in nursing. Maybe we'll have some other classes together. Great. That's good. If you have things that are important to you, I've had students that were really into like environmental activism. Put that up there if you want. And then another student will go, oh, I'm really into the environment too. I'm going to team up with this person, or, whatever it is. I don't really care how you form your groups. But, in some way, introduce yourself and then try to form groups. Now, I know that for some people that is scary, okay? But the reality is, just remember, you're all in the same boat, okay? You all have the same goal here, which is you just want to succeed in this class. You're like, I have to take this class. I don't want to have to take it again. I just want to get through it in one piece, hopefully learn some statistics along the way, get a good grade at the end of the class, and then move on with the rest of my degree, right? No one, this isn't high school. No one's looking to make fun of people. No one's looking to like be mean or, be exclusive or anything like that. You're just here because you want to get a good grade on your project in the class and do well and understand the material. So don't be afraid of anybody. Right? So it's just, you're going to introduce yourselves. Now, here's what I'll say. If you absolutely want to work by yourself, like some people are like that. Like I've never been a big fan of groups myself. I don't always work well in groups. You really want to work by yourself, you can. Just realize you are upping the difficulty level of your work significantly because it's going to be that much harder to get help when you need it. And some people then start to feel overwhelmed. Go, oh, I have too many questions. Even if I go to Dr. Frederick's office hours, I just have too many questions. It's getting away from me. So having a few other people that you can get together with, helpful. Okay. The target that I've seen work really well seems to be 3 people, because the truth is we are going to lose some people along the way. You're going to have people in your group. Some of you, what I should say is we have people in this class who are not going to reach the end of the walk here. They're not going to reach week 18 because they're either going to drop the course or they're just going to ghost the class, right? They're just all of a sudden you won't hear from them anymore and they won't answer your texts and stuff like that. So if you have 3 people in your group and somebody decides to ghost everybody, you still have 2 people, right? If your group dissolves, talk to me, because sometimes what will happen is in week 6 I'll go, okay, I got 2 people, both of their group members have vanished. Can you 2 work together, or maybe be absorbed by another group or something like that? It's just helpful, because it's really confusing. Like hypothesis testing, we get into it and you're like, what? I do not understand anything about hypothesis testing. And then you feel like you have no one to talk to, and you're like, I've been in this class for 15 weeks and now it's all going to fall apart at the end because I don't understand hypothesis testing. Really, really helpful to have people that you can go ask questions to, okay? So I highly recommend try to get in a group of 3 people. Once we go above 3 people, sometimes what happens is we start getting into more of like a social hour versus statistics, and it can be, we sort of start to, some of the benefits start to get diminished, because it almost becomes like a fun get-together, which is fine if that's how you want to do it. But you also need to make sure you're being productive in the class and getting the class work done in order to do that. So form a group of 1, 2, or 3 people. If you came into the class with a friend and you really just want to have a buddy group because you know that person, whatever. I'm not going to judge how you do your groups. Just realize I don't recommend working by yourself. But you can. I highly discourage it. 3 people's about what you want to shoot for. And if down the roads your group dissolves and you all of a sudden feel like you're alone in the class and that's scary, email me and I'll see if I can have a group absorb you or something like that. Okay. So and hopefully once we're back in the classroom, that'll get even easier. You could even do it yourself. You just ask another group. You show up to class one day and they're talking about how one of their group members ghosted them. You're like, well, I need a group. Can I join your group? And then it'll help. Okay. So do that. This is what, again, one of the themes that you hear me talk about so much, because I honestly think it's like half the issue in education is procrastination. If I was forming a group, I would probably try to form groups with the people who put the first discussions up here, the first comments up here. Those would be good candidates of people to form groups with, because those are people that they don't wait till the deadlines. They're trying to get their homework done. They're trying to get it done early, get it done right. Go for it, right? So that's just, it's just a suggestion. Don't sit on this. The people that show initiative and get in here early, sometimes those are the groups that they totally know what's going on, because it's a group of 3 people that are all, interested in getting A's and getting their work done, completed early, well, on time, all that kind of stuff. So, but you can do that how you want. So, okay, let's pause the group discussion, and I think it should be safe for me to take roll at this point. So let's see. So we got one person. Let's see. What is today? Wednesday? Okay. Let's see who we got. Also, if there's any questions, feel free to throw them up there. And thanks, the people on YouTube who are putting their names up there. Thank you, because I'm going to need you to do that in just a second. So thanks for getting those up there. Anyone who hasn't, if you're not in Zoom, make sure I can figure out who you are. You don't have to put your whole last name if you don't want, but make sure I can identify you. Okay, so let's see. Oops, how did I get you in here too? Javon, is it possible that your last name on my roll starts with an F? Because I'm seeing W. Is it? Are you possibly enrolled in the school with a last name that starts with an F? Let me know. Otherwise, we have a issue with two different Javons. Are you there, Javon? Anyways, Javon, if you're there, catch me after class. There's, I have to make sure I have something's weird with the naming in my role, so I just want to make sure we have everything correct. So please see me, Javon, at the end of class, and I will make a note here. Otherwise, so I want to make sure there's no Jose A, Joshua D, Willie D. I think Willie D is gone, maybe, huh? And then Javon, I'm just double checking on your name because there's a name discrepancy. So I just got to get that right. Okay. Okay. So with that said, great. We took roll. Check in with Javon. Okay. So we talked about the first discussion. I took roll. Great. Okay, so what is this project I'm talking about? And how are you all going to work together? So what's going to happen is you're essentially, there's this big push in, especially in mathematics, but education in general. It's a big push that we do what's called authentic assessments. Because if you think about it, and some of us have been sort of saying this for, the last 15 years, and some people even before that the way we test people in school is maybe not the best way to do it, right? There's all sorts of different perspectives you can look at which say that maybe just lecturing to a class and then giving them a test is maybe not really measuring students' knowledge of a situation. It's easy to do. It's very easy for me to write an algebra test, give it to you. I can grade it in a couple minutes. I put a score in the grade book. But did it really measure your learning? And more evidence is suggesting probably not, right? And some of us have seen that firsthand. I've taught courses before where a student could come up, totally have a conversation with me about a topic in the class. They could totally do problems when I'm working with them, when I'm helping them. They can do problems. I had a class where we had two types of exams. There was a presentation where they had to get up in front of the room and give a presentation on a topic, and then everyone took a written test. And I would see students who could get up in front of the room. They could do the problems on the board in front of 30 other people. They were great. As soon as I hand them a written test, they get anxiety, their brain freezes up, and they fail the test. And it's like, I just saw you do this problem on the board in front of 30 people, which a lot of people panic when they're in front of 30 people. You just did it fine, but when it's on a piece of paper and you have to write it down, you panic. So there's a lot of research that shows that, ways we've traditionally written tests are maybe not fair to certain groups in society, right? Based on there's all sorts of perspectives you can take on it, both from socioeconomic status perspectives that, a lot of tests are sort of maybe written for people at the top, of the socioeconomic ladder, all sorts of perspectives. So we're trying in education to change the way we do testing. And to me, statistics is one of the easiest courses to change because the subject of statistics is begging for applications and projects and actually getting your hands on and actually doing statistics. It's a little harder. In an algebra class, it's hard for me to say, okay, go out into the world and factor. You're like, well, okay, I can factor in the classroom, but I'm not really sure what you want me to do. Statistics, there's statistics everywhere, right? You can take almost any topic and turn it into a subject for statistics. So I have found it's not only is it easier to do these authentic type assessments rather than just, easy testing, of students, but I'm also seeing students learn better. So not only are we getting a better measure of what you've learned, students are learning at a better rate because you're actually doing the statistics, right? It's one thing to just sit here and talk theoretically about here's how you would do good statistics, and then you kind of remember that and you can get their answers on the test right. But when you're actually doing it, you go, oh, this is what he was talking about in class. This is harder than I thought it was. This is going to take some effort. I'm going to have to think my way through this. One example is one of the things we will talk about in this course is picking good statistics questions to ask people. If you're going to give a survey, it sounds like it's super easy, right? Well, I'm just going to ask these 5 questions. Well, once you dig into it, you realize, oh, maybe it's not as easy to pick questions as I thought it was. Some of you are going to figure out this the hard way. When you submit your survey questions to the survey and then everyone takes it and you get back answers that are a mess, you're going to go, oh, we could have asked that question in a better way and got better answers, right? So being hands-on with statistics is really the way to learn statistics. So what's going to happen is we're going to conduct a survey in this class, and you're both going to be, each of you is going to be the person asking survey questions, and you're going to be the person answering the survey questions. So what's going to happen is your group's going to get together after you form your groups here in a couple weeks. We've got maybe a week and a half, 10 days or something to form your groups. Shortly after that, you're going to come to me with some survey questions, and I will give you some more guidance on what to expect from those survey questions, but we don't have the language yet to describe those things. You don't know yet what quantitative data is. You don't know yet what qualitative data is. We haven't had discussions about how to ask good statistics questions. We don't have any of those tools yet. You will in a couple weeks, but you don't have them yet. So as you learn those things, then your group is going to pick a subject, and then you're going to pick at least 5. Some people ask more. If you want to ask 6 or 7 or 8 questions, that's fine. Don't ask 20 questions, because if we have 10 groups all asking 20 questions, the survey is going to get a bit overwhelming. But you're going to come up with some survey questions. We're going to use StatCrunch for that. So I'm going to create a StatCrunch survey, which you get to use when you buy your license for the class. You get to use StatCrunch included in that. You're all going to take the survey on StatCrunch. And I'm going to say this, I really need everyone to take it. We do not have a lot of people in this class. Your survey results are already going to be way smaller than we really would like them to be. So if we only get, say, 60% of you to take the survey, it's going to be a lot more difficult for you to do your projects. So we really need each one of you to do the survey. In fact, I'm gonna make it an assignment where you're gonna show me. You're gonna post a screenshot for me of you finishing the survey, and then I'm gonna give you points for that. Okay, so make sure you do that. And what are good topics for the statistical survey? Anything you want. Have you ever wanted to just ask people at the school a question? Obviously, it needs to be appropriate and respectful and safe and that kind of stuff. But if there's just things you've wondered about, I've seen all sorts of topics in the last few years since we've started doing these projects. Some people want to know about environmental issues, so they ask, what are your opinions on the environment? How important is the environment to you? Is it just kind of important? Is it really important? There's always a few basic questions that get asked a few times. Age, height, weight, some of these kinds of things are just sort of, at least one group is going to ask those. But you want to have questions that go together, because part of statistics is making connections between different things. Sometimes what you will find is two things that, we're these humans, and we like to think that, well, humans are separate from the other animals because we have these amazing brains, and look at all the things we do with these brains. We've created iPhones, and we've put telescopes into space, and aren't we just so smart and amazing? But by and large, our brains are not quite as advanced as we would like to lead ourselves to believe. Our brains make really bad connections and really bad conclusions a lot of times, right? Both in the absence of statistics, we make really bad conclusions, and using statistics, we make really bad conclusions. This is why there's that saying that a little knowledge is dangerous. Statistics is one of those. Someone learns a little bit of statistics and then they get all like, "Oh, I'm good at statistics now," and they go out and try to use it, and they use it in completely inappropriate ways, either on purpose or accident. A lot of times just unknowingly. People think they know how to do some statistics, and they do it really badly, and then they make bad conclusions on things. For instance, one thing, your brain will always try to search for cause and effect. Well, one of the things you're going to hear throughout the statistics course and when you do statistics in general is that correlation is not causation. Your brain wants to tell you it's causation. Your politicians use this to create fear and anxiety inside of you to get you to take a certain point of view. But causation is a whole lot harder to prove than just correlation. What does that mean? Two things that are connected don't necessarily cause one another. But if we as humans, our brains, if we see one action happen and then after that another action happen, our brain immediately tells us that the first thing caused the second thing, but it does not, right? There's some pretty famous cases that we'll see come up that we'll talk about throughout the semester. For instance, ice cream sales rise at the same time. There's a strong correlation. Ice cream sales rise at the same time that shark attacks rise. And you immediately go, I wonder why. I wonder which one's causing the other one. Is it that when you eat ice cream, you become tastier, so the sharks are more likely to bite you? No, that's ridiculous, right? What about the other way? If you get attacked by a shark, does that make you want to go eat ice cream? No, that's equally absurd. So why is that? Why would it be that ice cream sales go up when shark attacks go up, and when shark attacks go down, ice cream sales go down? I wonder why that is. Well, neither one of those things happen very much in the winter. They both happen a lot in the summer. So what you see is there's a third thing taking place that affects ice cream sales. That is, in summertime when it's hot, ice cream sales go up. People also get in the water at the ocean. Shark attacks go up. In the winter, people don't eat as much ice cream because they're already cold. They don't need to get any colder. They also don't get in the water, so the sharks can't attack them. It's one of those things that's easily avoidable. Just don't go in the water. A shark can't get to you, right? So that's one of those situations where your brain will try to force a cause and effect. Like I say, your politicians do this all the time, right? They know they can trigger a fear and anxiety response in you and get you thinking a certain way. So they'll talk about two things that happened and they'll present it as if A caused B. But a good statistician will look at it and go, yeah, A didn't cause B. Those are just two things that happened. But one doesn't necessarily cause the other. So we have to get out of this thinking that we always think that if two things happen at the same time and kind of in the same area, that one must have caused the other. That's not what we're doing. We're trying to make deeper connections, like with the ice cream and the shark, and go, I wonder why ice cream sales go up when shark attacks go up. Oh, it's because of this other, what we call hidden variable, or they sometimes call it a confounding variable. Oh, it's temperature. Temperature is this thing out. We didn't even talk about temperature in our conversation, but that's actually the important connection, is temperature. That's the kind of stuff we're trying to do with statistics, is make deeper, more insightful connections. Another example, the more vehicles you own, your life expectancy goes up. Those two variables are very closely related. Does anyone have an idea why those are closely related? Why the more vehicles you own, automobiles you own, usually at least one person gets this, why your life expectancy would go up? Anybody? The answer is money, right? People have more automobiles, have more money. People have more money, have better health care. So it makes sense. They live longer. But your doctor's not going to prescribe you to go buy an automobile. He's not going to go, well, people who have more automobiles live longer, so you should go buy 3 cars in addition to the 2 cars you already have, and then you're going to live forever. That's ridiculous, right? But there's this third piece that's missing of money. People who have money, more money you have, you're going to have better health care, you're going to have better automobiles. those two, one doesn't cause the other. They're affected by a third unforeseen variable. Those are the kind of things we want to get our hands on. So you're going to pick a topic that you and your group will come together and pick a topic that you find interesting, that you want to ask questions about. There's been a lot of topics about COVID, right? Questions like, how many units did you take before the pandemic? How many units are you taking now? How many online units did you take before COVID? How many online units are you taking now? How many hours did you work at your job before COVID? How many hours are you working at your job now? All these kinds of questions. And those are really good because you can kind of do a before after and try to draw a connection between those two things. What's changed here that you're now working half as much as you used to, or twice as much, or whatever your results find. So COVID's a big one. Eating habits are a big one. Asking people about their eating habits. A lot of questions about that. Exercise habits. A lot of questions about people. Everyone wants to know how much everyone else is exercising, apparently. That's a big one. The environment comes up. Usually at least one group picks an environmental topic that they want to talk about. There was a group, I had one group that looked at people's opinions of police officers. There were some problems with the way they conducted their statistics and their conclusions that they came to, but that was a topic that was some people it was a group that kind of formed based around, I think they were all, or at least part of the group was like criminal justice students, and so I think they kind of had a pro-police bias to their group, so they were, which is difficult to get around. If you're entering a survey because you are invested in having a certain outcome, then sometimes that outcome is going to come out because you're setting everything up in a way that you want a specific outcome to come out. So you have to be a little careful about that. But some of their work was good, but it was a little overly biased. So if you're going to pick a topic that you're passionate about, please do be prepared to try to recognize your own bias and do things in a way where you can, really let the data inform you. No, what you don't want to do is try to construct the data or massage the data to fit your beliefs you already have. You want the data to inform your beliefs, right? That's part of the scientific principle is if data shows up that disagrees with what you believe, you got to change your mind, right? That's what science says. We used to think some things in science, but we came up with better science and said, oh, okay, we need to improve this, right? We're seeing less and less of that in society at large. People just sort of cling to what they want to think, and they sort of ignore the stuff that disagrees with what they want. Statistics, science, mathematics doesn't work that way. If you have an idea and the science and the mathematics and the statistics refutes your idea, the responsible thing to do is to change your point of view to match that. Otherwise, you're just sort of sticking your head in the sand, right? So if you that's great if you pick a topic that you already feel very passionate about. That's great, but do try to follow the data and let the data speak for what's going on. Don't try to guide things in a way where you're going to get a conclusion and then you can sort of use that for your own good. This is a thing that's done in statistics a lot, right? When the oil companies do work, do you think they're coming up with work that really says that, oh yeah, we should be using less oil? No. When the cigarette companies were doing all their work a couple decades ago, were they publishing work that says you should smoke less? No, right? So you always kind of have to wonder about this when people are invested in a specific outcome. Do you think that work is bias, right? If I work for the oil company and they are having me run statistics, if I publish a report for the company that says, yeah, we really should be cutting oil production because we're really messing up the environment, how much longer do you think I'm going to be working for that oil company? 0 hours, right? You won't work there anymore. Same with the cigarette companies. If you work for a cigarette company, you're not going to release statistics to your boss that says, oh, cigarettes are awful. We need to stop everyone smoking right now. You will lose your job. So you always have to kind of be aware of where statistics are coming from. And that's in this class. If you pick something that is important to you, that's great. But check your own biases and ask yourself, am I afraid to let the data speak for itself? And if so, then you have to wonder, why am I afraid to let the data speak for itself? Why is that? So you're going to create topics. Like I say, it can be all sorts of stuff. Anything you've ever wondered about other people, as long as it's class appropriate, right? There's, we're seeing more questions about gender, that kind of stuff coming into, as things take a larger role in society, people are curious about it and they want to ask each other about it. So as long as things are done respectfully and responsibly, we can ask questions about, a pretty wide variety of topics as long as it's school appropriate. And then what you're going to do is you're going to come up with questions. And that sounds easy. Oh, we'll just sit down in 15 minutes. We'll figure out 5 questions. It's a little harder than that because you're going to have, although you only need 5 questions, they have to be specific types of questions. Okay, you're going to have 2 quantitative questions, 2 categorical questions, and a binary question, a yes/no question. So you don't even know what those words are yet. We haven't even talked about that. We will be expanding on that in the coming chapters. It's kind of early in the course where we get to it. Quantitative, quantity means an amount. So in other words, numbers. How old are you? How tall are you? How many times a week do you exercise? How many times a week do you get fast food? How many times a day do you eat? Right? A lot of it's one of the big things now in health is, not everyone's just eating 3 square meals a day. People are eating at strategic times and amounts and stuff like that. All those types of questions are measuring an amount. That is what we call quantitative, quantity. It's really important that you learn these early definitions because if you don't, the tools that come later you're not going to be able to do them, right? So we just talked about quantitative questions. There's also qualitative. I know those words sound so similar to it. Qualitative we also sometimes call categorical. Those are questions where you're putting people in boxes, right? So for instance, what's your eye color? Oh, you have blue eyes, I put you in the blue eye person box. Oh, you have brown eyes, you go in the brown eye person box. Oh, your eyes are green, you go in the green eye person box. So you're breaking people up into groups that are not quantitative, they are not numbers, they are not amounts, right? So it makes sense that you really have to know the difference between those because clearly the tools we use for crunching numbers, quantitative type stuff like an age or a height, we have to use different tools for crunching data that is, say, eye color, right? Like it's pretty clear we can take the mean of everyone's age in the class. That's easy to do. Can we take the mean of everyone's eye color? No. What is that? What would that even mean to take the mean of an eye color? It doesn't mean anything. So I see students sometimes struggle with this towards the end of the semester when they don't know their definitions. They get confused about what tool they're supposed to use when because they don't know. I don't know, is this question quantitative or qualitative? I don't know the difference. Well, then you're stuck. You're not going to be able to do any subsequent steps because you don't even know what you're doing at that moment. So these early definitions, I'll be talking about them. You'll be working on them in the lessons that you do online. You're going to learn quantitative, qualitative, and then the binary type questions, yes, no questions. So you're going to create 5 of those, right? Loosely based around your topic, right? I give you a lot of freedom in this project as long as you're doing the things that show me that you know statistics, right? So you're going to create a survey, and that will be, I haven't released it yet because you haven't even formed your groups yet, but you can see the next thing I'll be releasing after your project groups is the survey questions. You're all going to come in and you're going to post your survey questions for me. And I'm going to create a big survey, right? We don't have a full class, so I don't know. Maybe the survey will only be around 80 or 90 questions. I've had classes where the survey was like 150 questions. Might sound like a lot, but when you figure that you're probably only going to spend 5 seconds on each, on average, you might spend 5 seconds on each question. You can get through a 100-question survey in like 5 minutes, 6 minutes, something like that. So it's not too hard to do. So we'll create a giant survey. That survey will be in StatCrunch. I will then release the results, and then you all have statistical data from your questions. That's great. You created questions. Now you'll have data, and then each chapter where we learn about how to use data in different ways for statistics, you can apply that to your survey questions, right? And then you're going to create a project, a video at the end of the semester presenting your questions and your data and your conclusions and using all of the tools that we've used throughout the semester. You should try to use every major tool that we learn in this class, right? So you've got your summary stats that we're going to learn pretty soon here. That's things like the mean, the median, the standard deviation, quartiles, all that kind of stuff, which if those words sound scary because you don't know what they are, that's okay. We haven't learned them yet. You're going to do that. We're going to learn about project visuals, histograms, bar charts, pie charts, all sorts of different ways, dot plots, box plots, all sorts of different ways of presenting data. You're going to create visuals for your project. So when we get to the, here on this chapter about organizing our data, displaying our data, graphical misrepresentations, then I don't have it in here yet, but you're going to, actually, I think I have it in the chapter after that. You make your project visuals. As you can see here, you're going to make histograms. You're going to make pie charts. And here's the thing. This is what's so awesome. StatCrunch will do it for you. You just have to go and tell StatCrunch how you want it set up, and it's going to create these visuals, and you go, oh, that's great. I'm going to save this in a file, and then I'll come back to it at the end of the semester. That's why I say at the end of the semester, a lot of the work for your project you will have already completed. At the end, you're just putting it all together into a video. Okay? Remember, each one of you has to do your own work. You're just in groups to help each other answer questions and stuff like that. So you'll create project visuals. We have a chapter on correlation and regression. You're going to do correlation and regression on your problems. When we do the chapter on confidence intervals, you're going to make confidence intervals for your project. When we do the chapter on hypothesis test, you're going to do the hypothesis test for your project. So at any time we're learning a chapter in the class, you're also relating that to your project data, right? You're doing that work, and we're doing it along the way throughout the semester so that you're not like in the last 2 weeks of school, like panicked, like I have to make this huge project and like all in the next 2 weeks. No, the work should already be done. And that last week, you're just making a video, putting all your work together. Okay. Is basically how that's going to work. So let's see. Right. And I'll be releasing these as we do the chapters. But pretty much almost, I think there's like 2 chapters where I don't have a project-related discussion at the end of it because it's really kind of hard to fit it into your like certain topics. There's like 2 that are really hard to associate to your project. It's not clear like how everyone would do that. But that's kind of the idea of what we're going to do here. You're all going to create questions. We're going to make a big survey. You're all going to take it. We'll have the data responses for the individual questions. And then you're going to use the statistics that you learn to understand your data. That's what we're doing here. And again, I want to make this clear that this is a learning experience. And the project that you create at the end of the semester is really about showing me what you learned. Okay? To a journal, because as you'll learn, unfortunately, even the way that we're saying, okay, this entire class is going to take the survey is fairly problematic from a statistics point. Most of you will understand that in another week or so, maybe 2 weeks. I forget where that comes up. But you'll understand why, that was kind of a bad way to collect data. Yeah. It is, but we're not trying to do actual research. This is a learning exercise for you to do this. So I think sometimes at the end of the semester, people try to hide their mistakes in the project. So if something really didn't go well, they're like, I'm not going to talk about that. I like my confidence interval like is weird. I'm just going to skip it. Don't do that, right? Making mistakes is part of the learning process. And by explaining to me the mistakes you made, why you realized they were mistakes, and how you would do it differently if you had another chance, well, that just showed me that you learned something, right? This culture that we live in, we're always supposed to be hiding our mistakes because someone's going to make fun of us, or someone's going to think we're dumb, or whatever. But what you have to realize is that learning involves making mistakes. You literally can't learn things without making mistakes. It's like those of us who do mathematics, people look at us and they're like, oh, you just like are an ace at mathematics. You never get anything wrong, right? No, I make mistakes all the time in mathematics. Everyone who does mathematics does. The difference is when I make a mistake, most of the time I figure out that I've made a mistake. I can see it and go, something's not right here. And then I can go back and I can fix it. And then later people don't even realize I ever made a mistake because I fixed it, right? But also that's just part of learning. Part of learning is that you make a mistake and go, that's I didn't do that right. And then you make that mistake, and then you don't make that mistake again, hopefully, right? You learn from it and you go, I don't do it that way. And then you're better at it, right? So don't necessarily hide your mistakes. If something went wrong in the project, feel free to talk about it and go, yeah, I learned because I messed up here and now I would do it differently. Even though we're going to talk about survey questions, there still will be some students who submit some really bad questions. And I've had students in their project go, yeah, we messed up because we asked bad questions, and we now realize this is why those questions were so bad. And here's the kind of questions we would ask if we could do it again. Okay, well, that just shows me that the student learned something, right? They went from not understanding questions to now they understand it better, right? And this, again, goes into that authentic assessment. I've taught this class for years when we just did traditional tests. We would do the part where we talk about good questions and bad questions, and students would go, oh, I totally get it. But now that I have students submitting questions, it's clear they don't get it because they're still asking really bad questions, right? So, for instance, a good question, and I don't mean a good question in the sense of this is one you should ask. I just mean a good statistical question could be, what is your age? Okay, once I have people's age responses, I can find the mean, the median, the mode. I can make a box plot. I can make a histogram. There's all sorts of things I can do with that data, right? A bad question would be, what is your favorite childhood memory? Well, what you're going to get if you ask people their favorite childhood memory is you're going to get, what do we have? 18 people in the class? You're going to get 18 different responses, all of which are written responses that are like a story. Well, how are you going to run statistics on something like that? The answer is you're not. It's a bad question because it's a bad question. I mean, it might be a good question in other settings, but from a statistical point, we can't do anything statistics-wise with a question like that. And that's going to be important because when the data comes back, you're going to have to fix some of your data because some people aren't going to follow directions and they're going to answer incorrectly. That's another lesson you're going to learn. Even when you tell people exactly what to do and you think, I've got this bulletproof, no one's going to screw this up, someone will screw it up, okay? Think about height. If you tell people, or if one of your questions is, what is your height? So someone's going to give you their answer in inches. Someone's going to give you their answer and say 5'8" inches. Someone's going to put that notation where it's 5-8-. Okay. Someone will just put, I'm 67 inches. Someone will just say 67. So what you're going to get is all these different forms of answers. Then you're going to get to go back and convert all of those answers to one consistent form. That's not fun, right? So what you want to do is ask the question carefully and say, how tall are you in inches? And then at least then 90% of people will answer the correctly. They'll put it, you just want me to put a number because you've already said that the unit is inches. Okay, 67. And you'll get 90% of people do it that way. Some people don't read very carefully, or they, there's a tendency for people to skim. They get halfway through the sentence or the question, and then they answer it. They don't read the whole thing. So you're still going to get some responses that you have to go through and edit, but it's much better to edit 2 or 3 responses than it is to edit 18 responses, right? That's tedious if you have 5 questions with 18 answers and you have to convert 18 responses. It's a pain. So we'll talk about that. But you can start thinking about it, and think about it when you're doing your lessons, when the discussions we're having in class, the videos and lessons that you're watching when you're doing your project. You can start thinking about, oh, my group is talking about asking a question. We better be careful not to make this mistake that the lesson's talking about right now. We should be strategic and be a little bit more clever about how we ask our question so that we get good responses. Okay. And ask how you want people to respond, right? You might give people specific levels. Like, sometimes you have to wonder about, like, do people even know, right? So you ask people, what's your high school GPA? Well, people might not remember their exact high school GPA. So you might give people levels. Is your GPA from 3.5 to 4 and 3, or is it from 3 to 3.49, 2.5 to 2.99, all this kind of stuff. And then make sure your categories don't overlap. Sometimes people will go, is your GPA from 2.5 to 3? Or is it from 3 to 3.5? Or is it from 3.5 to 4? Well, the problem there is, what if your GPA is 3.5? Well, then you fit in the category of 3 to 3.5. You also fit in the category of 3.5 to 4. So which one do you check? That's why you want to go 3 to 3.49, 3.5 to 4, so that it's people can only fit into one of those categories. So hopefully you're starting to see it takes a little bit more thought to ask good statistical questions than just throwing them out there and saying, here's a question, give me a response. You have to really lead people and guide people to know how to give the right kind of an answer that you want. Not that you're trying to affect the answer they give, because that's a sort of an unethical way of doing statistics, but you have to set up the question that it's very clear when that person knows how they want to answer, that they can answer in that way that's going to be, you're going to be able to crunch the numbers on it, right? So you want to do that. And ethics is a big part of statistics. I kind of mentioned that with oil companies and smoking and stuff like that. Like, there's literally books called How to Lie with Statistics, because it's easy to come out and be misleading with statistics. And I will tell you, as someone who has a PhD in mathematics, when you start talking to most people about numbers and statistics, their eyes just kind of glaze over and they're like, I don't know, you sound really smart. I'm just going to do whatever you say. You seem to know what you're talking about, so just kind of tell me what to do here and I'll do it. That's a lot of power that you're giving to someone else, right? And that's why our politicians do it, because if they start sounding like they're really smart and we all just kind of glaze over and go, I don't know, it sounds like whatever he's saying sounds smart, I'll just go with him or her. That's a lot of power you're giving over to people to make decisions for you, right? So understanding statistics, and thinking about ethical ways of doing statistics mean that we are not misleading other people, and then also we have the tools to not be misled by other people. We can see when someone, intentionally or unintentionally makes a really bad statistical conclusion on television or on the news or whatever. You can stop and go, that person doesn't know what they're talking about. That's not right. And you can be prepared to have, keep that power for yourself. Not let someone, they sometimes call it persuasion through intimidation, which is, if I'm in a room and I can sound like the smartest person in the room, a lot of people are just going to go with whatever I say. But you don't want to hand somebody that power over you. You want to be able to say, no, I've looked at the facts and I've thought about it, and I think this is what we should be doing, right? That just usually sounds like a better way to go, that you can make your own decision rather than feeling powerless to make your own decision and just have to go with what someone else says. So just start, when you're doing the lessons, kind of start thinking about whatever topics your group decides your project might go in. Start thinking about that and thinking about how you want to do that. Okay. Okay, so chapter 1. So you should be starting chapter 1 and starting to work through that. So what do we have? We have about 20 more minutes. And like I say, we're going to talk about the project all the time. So that's another reason why people who skip class are going to be at a huge disadvantage. Your grade will suffer because you're going to miss me talking about the project. And you're going to go, well, I don't remember you saying that, right? Because I said it in class when you weren't there or something. So it's really important. Almost every time we meet, the project will kind of come up in one way or another, where I'm either pointing out, make sure you do that discussion that's on Canvas, or okay, now that we've talked about correlation, here's what I want to see in your project on correlation. All that kind of stuff, you're going to be getting that pretty much every time we meet throughout the semester. So really important that you keep the attendance going well. Okay. Right. Okay. Oops. We talked about the project, first discussion, intro to statistics. I kind of already talked about statistics in general, kind of just a brief approach to statistics. Statistics is not mathematics. It has mathematics in it, but it is really a different subject than mathematics. By and large, what most people consider mathematics, they will say, well, there's a specific answer. That's usually true. When you solved an equation in your algebra classes, the answer was either right or wrong. It was very clear. Statistics doesn't work that way because, like I say, you could have two people working on a very similar topic and they would take very different approaches because they're trying to show different things, right? And I know this is unsettling for students, and I can understand why it can be frustrating, but sometimes in statistics there is not the right answer, like, the right answer. What is the right way to do it? I get that question in like algebra sometimes, like, what's the right way to do this? Like, even in algebra, sometimes you have different ways to do something and there isn't necessarily the right one. You usually in algebra, at least you'll end up with the same answer at the end. But in statistics, you could take different approaches. So like you and the people in your group are going to be asking the same questions and crunching the same data, but you might decide that you think the data is best represented in a pie chart, and someone else might think that the data is best represented in a bar chart. Well, which is the right way to do it? There isn't the right way to do it. For the point that you're trying to make, a pie chart might be the right way to do it. For the point the other person is trying to make, a bar chart might be the right way to do it. And this is frustrating because, students sometimes just want, like, just give me the answer. Just tell me how to do this. But that's kind of me doing it. Like, I know how to do these projects. The learning process is you figuring out how to do these things, right? So you have to sit down. Here's a nice thing about StatCrunch. It takes, the speed of computers, a tiny fraction of a second for StatCrunch to create these different graphs for you. So what that means is you could go in and you could make 20 versions of things and then pick the one that looks the best. That's one way to make your project look better than the rest. Some people are going to go in, just use the defaults, create a histogram and go, okay, I'll put this one in my or a bar chart or whatever. I'm going to put that in my project. Some of you will make 10 different bar charts and go, ooh, this one is showing me some interesting data that doesn't show up in these other ones. I'm going to use this one. That person, even though they only spent about an extra minute creating bar charts, their presentation is going to look much better because they have something interesting. They found the interesting piece in the statistics. They found where the connection is being made to some other piece of data or something that is interesting to hear about. And it will look like that person put in a lot of more effort when sometimes they only put in a little bit more effort, but the outcome was significantly better. Okay, so that's helpful. But again, at the end of the day, there is no right answer that your histogram has to be set up exactly this way for it to be right. There's lots of ways to do things wrong. So I don't want you to think that like anything's fine and anything you do is okay. That's not true. But you and someone else in your group may set up your histograms a little bit differently, and that's okay. The question you want to ask yourself is, why am I doing it this way? And if the answer is, I'm doing it this way because I don't want to think about doing it any other way, then you're probably doing it poorly. If you can ask, why am I setting up my bar chart this way? And the answer is, well, I tried setting it up this other way and that didn't work. And when I compared the 5 bar charts that I made, this one looked unique and it looked like it was showing some part of the data that didn't really show up in these other bar charts. And it supports the claims that I'm trying to make. Okay, well, then you have some good reasons why you're doing it that way, right? That's really the answer, is does it do what you want it to do? Like when you're doing math, you're really crunching numbers to get to some end. That's not necessarily what statistics is. In statistics, think of it as like, I sometimes think of it as an argument, like say, like a courtroom, okay? What do you do in a courtroom? You have a jury. You have a group of people that you're trying to convince of something. If you're the prosecutor, you are trying to convince people that the defendant is guilty. If you are the defense attorney, you are trying to convince the jury that your defendant is not guilty, right? So both lawyers have a point of view. So what do? They each present evidence. They construct a narrative, and they give evidence for that narrative. So the prosecutor may say, well, we think that the defendant entered this property at this time and attacked this person, and here's the evidence that we have for it, and blah blah blah. And they've created a story, a narrative, and they're giving supporting evidence for it. And the defense attorney may get up and say, well, we actually believe that the defendant was at a nearby location, but he was actually at a bar down the street at the time, and it was a different person who entered the premises and committed the crime, and here's the evidence that we have for that, right? We kind of understand how that works in the criminal justice system. You're kind of doing the same thing with statistics. You have a bunch of data, and by crunching numbers and using all the statistical tools you're going to learn this semester, you create evidence. And then you create a narrative to describe how that evidence fits the story that you want to create. So I might create the narrative that while there is no direct connection between ice cream sales and shark sales, there's no cause and effect, we can see that those both go up at the same time that the temperature goes up and down. We see the same effect happening in the ice cream and the shark attacks. And here's all the statistical tools that I have to support that. Here's the visuals that I have. I can put the temperature graph, and I can put the ice cream graph, and I can put the shark attack graph all on the same graph and go, look, they rise and fall at the same time. That's a piece of evidence to support my claim that temperature affects ice cream and shark attacks, right? We can create confidence intervals and hypothesis tests, which we haven't learned yet. So if that sounds scary, don't worry. We'll get to that at the end of the semester. But you can create a confidence interval. You can create a hypothesis test. You can talk about means and medians and all sorts of stuff. It's evidence for the narrative that you're trying to construct. So if you're trying to, maybe your connection is that we think that people have exercised less since we've been social distancing than they did before the pandemic, then that's your narrative. We think people are exercising less. Okay, now you're going to present the data. Well, we can see that these are the numbers of people exercising per week before the pandemic. Here's what they're doing now. And as you present that data, you are creating evidence for the narrative that you are trying to construct. But you can also imagine everyone doing that is going to have a little bit different perspective. You're going to use slightly different visuals. You're going to construct your confidence intervals a little different. Your hypothesis tests will vary a little bit. So there is wrong ways to do things in statistics, and there's bad ways of doing statistical analysis. But there's also many ways of doing it well, right? I hate to even use the word doing it right, because that sort of implies that there's one right way to do it. There's not. There usually is a number of ways of doing it well, right? That where your evidence does a good job supporting the claim that you make. And that's really what you want. If you're doing it ethically, if you're doing it responsibly, then you will have a good narrative because it's supported by the evidence, right? We have that evidence there that is reasonable and believable. We'll talk about unbelievable stuff as we go through the course, because probability is going to play a big role in this course. Things that are unlikely, we don't believe them. Things with a low probability, we don't believe. Things with a high probability, we do believe, right? If I show up to class late one morning and I say, oh man, sorry, I'm 5 minutes late. My dog was having some bathroom problems and I had to take care of it really quick. That's pretty reasonable, right? You're probably not going to think I'm lying or making it up. But if I said, sorry, I'm late, everybody, I was abducted by aliens and they just let me loose and as fast as I could get here, probably don't believe me, right? Well, why? Well, because there's a high probability that the first story is plausible. There's a very low probability that the second story is plausible. That's one, believe it or not, that what I just outlined, that's one of the lines of thinking we're going to have to learn to do in statistics. A lot of our statistical tools are based on the probability that thing is plausible, right? It doesn't mean it's true. It just means it's plausible. Those of you who grew up watching Mythbusters, right? You've got your plausible. It doesn't mean that thing happened. It just means it could have happened the way they said. That's actually reasonable that this thing could have happened the way that this myth, this urban legend is set up. It's actually plausible. That could have worked. Whereas if the probability is so low, we don't think this happened this way, right? That's one of the things we'll be learning about statistics as we go through this process. So, excuse me, when we are getting a little dry there. In class, I sometimes will be showing this. It's just a PDF version I found of a very popular. It's an old edition of a very popular statistics book. It's not the statistics text that we are using in this class, but is one that has really nice visuals and stuff that I can show you. So if you're looking for the exact page that I'm sometimes showing you in class, you're not going to find it. But I just use it as a visual tool so you can follow along. You won't see the visual tools in Zoom. You will see them on YouTube if you're following along there. So, for example, you're going to learn giving surveys and getting good results from your surveys much harder than you think. So, there's a very famous case. This was one of the first times when statistics went really, really wrong. Okay, so it was back I forget where it was. When was it? I read it earlier, but there was a, we see a lot of polls, and unfortunately in this country, since our presidential elections sort of ramp up about 2 years before the actual election, we see it for a long, long time. A lot of polls being taken. Who's going to win this presidential race? Who's going to win this Senate seat? Which is this proposition going to pass? All sorts of polls being taken, right? The news loves to do that. But you can do polls well and you can do them poorly. So there's a famous case where the Roosevelt-Landon election, they tried to conduct a poll. This was kind of in the earlier days, because you can imagine now we're connected in a way we didn't used to be. But that doesn't mean we could do better polling. We just sometimes can do easier polling. And one rule of thumb is the easier it is for you to collect data, the less trustworthy that data is, right? It's called a convenience poll. We'll talk about that in a few minutes. But basically, there was this magazine called the Literary Digest, and they wanted to conduct a poll. They wanted to know, okay, we're about to have the election. Let's see who's going to win. And there was this new invention at the time called the telephone that had just come out. Not that many people had telephones, but before that, if you wanted to conduct a poll, you had to go out and find people, and you had to go talk to them, and it took a lot of time to go find people and ask them questions, and that's a lot of work. And the Literary Digest said, why don't we just call people on the phone? I can just sit at my desk, and today I'll call 100 people, and I'll ask them who they're voting for, and then I'll write it down. That's great. This new invention of the telephone is fantastic, right? But remember, only rich people had telephones, and I mean rich people, right? I'm talking about like billionaire rich people. Like when you get to that point where, when you're a billionaire, you don't really have to work anymore, right? Because then you can take your $1 billion and have it earn interest, and then your money. That's what they call a capitalist. When you don't have to use your money, you have so much money that you can let the money make more money. Like the truly rich, right? Not just the person down the street in the big house, like truly rich people. Those were the only people that had telephones, right? Well, that's a very select group of people, right? Most of us who, I have to go to work. I can't just decide, you know what? I don't need money anymore. I've got plenty of money. I have to work. Most of you are the same way. If you're going to continue to have a roof over your head and food in your belly, you have to go earn money, right? So, when they started calling people to say, who are you going to vote for? They didn't stop to think that, oh, wait a minute. If we're just asking people with telephones who they're going to vote for, then we're really just asking rich, like ultra rich, not just rich, like the ultra rich, because that's the only people who had telephones at the time. We're really just asking them. Well, that skews your data because as we can see today in politics today, it was the same back then. The truly rich, they don't like paying taxes and stuff like that. So they have a very specific point of view, political point of view. So they were all saying, well, I'm going for this one candidate. And then the Literary Digest, they released their poll in their magazine and said, this Landon guy's going to win by a landslide. And then they were so wrong. Like a few days later, like to the point where people were like the Literary Digest lost some credibility because people were like, how did you do statistics this wrong? And they're like, oh, well, actually, we just asked super rich people. We just asked the equivalent of billionaires who they were voting for. When if you're just asking billionaires, then you're leaving out like the entire working population. Well, people who have to work for a living, we have a different point of view on things, right? Because, we have to wonder, like, am I going to have health care next year? Am I going to get a raise next year? Are interest rates going to go up? Can I afford to buy a home? Can I afford to buy a car? Like the people that were answering the telephone, they didn't have to worry about those kind of things. They have other worries, right? Whereas if you skip the entire working population of people, you're not getting those point of views into your poll. So who you ask questions to is very important. Right? That's why I mentioned convenience polls. It's very easy with the internet to conduct a convenience poll, but you can also realize that since it's so easy, your data is not good, right? Imagine I take the same survey question. Do you approve of President Trump, right? Let's imagine he was still in office, maybe towards the end of his presidency, the end of his term. Imagine that Fox News puts up a survey on the front of their webpage. Fox News poll, do you approve of President Trump? Okay. And MSNBC does the exact same poll on their front page. Do you approve of President Trump? Well, what do you think is going to happen? The people on Fox News are overwhelmingly going to say they support Trump. The people on MSNBC are overwhelmingly going to say they disapprove of President Trump. So you just asked the same question, but you got very, very different results. Why? Because you're pre-selecting the group of people that you are asking. And that is a no-no in statistics. Okay? So that's why when you see, you'll see a clip on Fox News and they're like, hey, we ran a poll and here's what people think. And the implication is, if you're watching that, is you're supposed to think, oh, this is how everyone thinks. No, this is how the people on Fox News' website think. You ask the same question over on MSNBC, you can get very different results. So it's always it's important not just to know the data from a survey. It's important to know, how was the survey conducted? How did you even do it? Basically, any survey that is conducted as an online poll where just anyone showing up to a website can take it is basically useless, because any website has a specific group of people going there, right? Fox News has one one type of thinking, people go to that website. Another type of thinking, people go to MSNBC. People who have like, there are people whose hobby is financial investment clubs where they all put a bunch of money together and then they buy stocks and they see how their money's going to go up. They're going to have one way of thinking. People who are environmentally active, they're going to have one way of thinking. So if you put a poll on an environmental activist website, you're going to get different results than the financial hobbyists, right? It's all very different. So one thing you have to be doing is randomizing the people who are going to take your survey. Imagine I went to school on campus. Imagine we're all going to campus again. It's like pre-pandemic days. And I say, I want to do a survey of, like, this actually happened. I'm on Academic Senate, and one of the things we had to discuss 4 or 5 years ago was they wanted to make a decision about tobacco on campus because smoking was banned. Well, smoking wasn't quite banned, but then we saw the rise of all the vaping, and it became kind of annoying because it's kind of annoying. I've literally seen this in classes where there's like 20 people huddled outside the door, all waiting for the door to be open so they can sort of move in mass into the classroom, and someone in the middle has a vape and they're just releasing these big clouds that 20 people are now breathing in. There was some pretty obnoxious behavior with the vaping for a couple of years there. And the school said, we need to come up with a policy. And at the time, what we had was there was 5 spots, I think it was 5 spots around campus where you could go smoke. And it was way far away from everything. So like if you're smoking there, you're not going to bother anyone else because you're probably 100 feet from the next person, right? But there was a big push to have a full tobacco ban. No tobacco products of any kind allowed on campus, right? So we needed to know. One of the things we do when we make a decision on campus is we try to get feedback from students because ultimately I'm a public servant, right? We're serving the community. So we can't just do that without knowing what the community wants. So we a lot of times get feedback from the student body. This is why when you elect your officials, it's not just trivial. Those officials come to our meeting, your student representatives, they come to our meetings and say, this is important to us. This is what we think. And those, I'll tell you, those are taken into account. That doesn't mean we always do what the student representative says, but we definitely take those opinions into account when we make decisions, right? So what if I went out and said, well, I want to ask people, I'm going to conduct a survey about smoking. And what if I just went out to the parking lot, and as people came in from the parking lot, I just asked them, do you support a tobacco ban? And then I would write that down, and maybe I asked 500 people. Okay, well, that's good, but I just selected for a group of people. It might sound like, what? It's just people getting out of their cars. Well, what about the people who ride the bus, right? And sometimes the people who ride the bus versus who ride the car might be in different socioeconomic classes. So that means I just left out an entire socioeconomic class, right? What about the online students? If I'm asking people coming in from the parking lot, I'm not asking online students. Well, maybe those people have... Maybe that's a specific group. Maybe people are taking online classes because of a disability that makes it hard to come to campus. Maybe it's working people who have jobs during the day and they need that flexibility to do their to do their work when they can. I'm leaving those people out if I don't include them in the survey. So it's you have to be very careful. So there's a question here. Great. So how do we find less skewed information? That's the whole game, right? As how do you do that? And I wish I had a good answer for you, like a simple answer. Here's what you do. The number one answer is randomizing. That's like the bare bones. If you run a survey and you don't randomize the recipients, that's probably a red flag, and you better have a good reason why you didn't randomize the people who are taking your survey. Sometimes it's legitimate. Like sometimes you'll see you'll read like medicals, something that was done for a medical reason. Well, there might only be 12 people in the whole world who have that disease. Like there's some super rare diseases where literally like 19 people have it. Well, in that case, you're pretty much going to have to deal with those 19 people. Right? You can't really randomize very much. You have to study those 19 people with the disease. But what we would do, say on campus, if I wanted to know about the tobacco ban, what I could do is I could write a little program that goes through and looks at all the 900 numbers, your ID number on campus. You all have a 900 number associated to your name. What if I wrote a program that looked at all, I don't know how many there are, 15,900 numbers. What if I had it randomly select 500 of those? Well, then it's probably going to include the people who work during the day. It's probably going to include people with disabilities. It's probably going to include people who drive to school. It's probably going to include people who ride the bus. It's probably going to include everything. Men, people who consider themselves male or female or non-binary. We're going to get a little bit of everybody in there. We're going to get people who are Latino in culture. We're going to get, hopefully you get, black representation in there. Hopefully you get everybody included so that you're not leaving out large groups of the population. So randomization is really important, and that's really one of the only ways that you can be sure that and there's more to it than just randomization, but randomization is a really important part of making sure that you've kind of included everybody if you can. Now it's hard to do because now I have a list of 500 students and I have to go find those people and I have to figure out how I'm going to get results from them. That's a whole lot harder than me just coming into my class and saying, raise your hand if you want a tobacco ban. But the statistical work of getting those 500 randomized names will be much more statistically valid than me just, asking the class who supports a tobacco ban. So usually that's the way it works in statistics. If you're going to collect your data in a way that is scientifically sound, it takes a lot of time and a lot of money. Okay, and you might go, well, what do you mean by money? Well, someone's getting paid, and the longer it takes, the more money you're paying that person. Right? So if it's my research and I can ask the class in 5 minutes what they think, or I can take a week collecting research from a randomized scenario, well, the school just paid me for a week of work to collect that data. So it is time consuming. It is expensive to do statistics well, which is part of the problem, right? The oil company, they can afford to pay their on-staff statisticians to conduct surveys because they're protecting their own money, right? They're protecting their own investment, even if they're doing it in an unethical way. Most people who just want to learn for the sake of learning don't have a lot of money to learn about specific things. So there's kind of a little bit of an imbalance there. So you really want to at least be thinking about it, and you'll learn about it in these lessons, and we'll talk about it more next time. How do you conduct polls in ways that are done well? And it's hard. It's hard to do. There was a famous case that came up, I don't know, now is it about 10 years ago, where there was one survey that was given to a ton of people, and there was 2 questions on that survey. I don't remember how many questions there were in there, but in one part of the survey they asked one question, another part of the survey they asked another question. And it's super interesting because they asked, at the beginning of, sort of towards the top of the survey, they asked, what is your opinion of the Affordable Care Act? And then later in the survey, they asked, what is your opinion of Obamacare? Okay. Those 2 questions got very different results. When people were asked about Affordable Care Act, very, very high rate of favorability. People really liked it. Okay. When people were asked their opinion of Obamacare, very, very low rating. People were not happy with Obamacare. So why is that interesting? Why is it interesting that people really, really liked Affordable Care Act and really, really disliked Obamacare? Is because it's the same thing. It's literally the exact same thing. Obamacare is what the Republicans labeled the Affordable Care Act because since many people were going to dislike anything that said Obama, they said, well, let's call it Obamacare, and then people won't like it. So it's the same product. It's the same exact thing, the same exact law. But when you call it the Affordable Care Act, people like it. When you call it Obamacare, people don't. So that's kind of depressing, just in that you have to be so careful how you ask a question, and if you're not careful, you can easily mislead people. If you ask questions in poor ways, you can inject that fear and anxiety into people that will get them to respond in a certain way. And if you're trying to do ethical statistics, you want to avoid that. If you're trying to get a certain outcome and you're willing to be unethical, you will ask it in that bad way. So for instance, there have been cases where they ask people, how much do you support taxes paying for social programs? And then people will respond pretty favorably. Yeah, I think some social programs are good. And then you ask, and then the way this has been done is they ask another question. How do you feel about people receiving money from social programs who are lazy and don't want to work hard? Well, as you put in that flavor to your question, who are lazy and don't want to work hard, you're working to trigger emotions. You're working to get people to have a specific point of view inside of your question. So you really want to try to work to not, like if you're doing it well, you don't want to push people one way or the other with your question, because now your whole survey has a bias to it, right? If you're trying to do good statistics, you want to answer your questions in a way where people are not answering out of emotion, out of fear, out of anxiety. You just want to ask the question, do you agree with higher taxes so that the city can provide social programs and pay for parks and teachers and support people who need some help, that kind of stuff? How you ask that question will get you very different answers. So just keep that in mind when you're constructing your questions for your survey. Put some thought into that. Make it a nice learning exercise. How should we ask these questions in a way where we're going to get good feedback for our answer, like we're going to get data that we can use, but also we're just getting people's opinions. We're not trying to nudge them in the direction of having a specific opinion, right? So I guess we'll end there. I went over about 10 minutes from the 90 minutes we're supposed to do right now, but we will end there. I will pick up next time with more of this. In the meantime, those of you who have not signed up with the homework, please do so. Those of you who have signed up for the homework, start working through your lessons and your homeworks and stuff like that, and we will discuss that more. Okay, thanks everybody. Anyone who wants to stick around and ask me some questions in Zoom, you're free to do that. I'm going to shut down the YouTube stream. Oh, Javon, if you could just, I don't know if you're still in the YouTube stream, or you can hop into Zoom. Can you just verify for me? I want to double check that on my roll you have a last name that starts with an F. If you could verify that for me, I could just make sure I have on my roll who I think I have. Otherwise, we will talk. We'll talk next time, okay? So please, like I say, feel free to hop into Zoom and talk to me if you want. Otherwise, good work, everybody. I will see you next week.